Thank you. Thank you.
Okay. Yeah. So let us just understand where all one person can use the space claim. So there are so many applications where you can try and use your space claim. You know that in the student version you have a bit of limitation, but if you get started, then when you have your like tool in your campus, that time you can explore more. Or if you are working with the student version itself, to initially get started, you have limitation for using a limited number of components, but you don't have limitation that you cannot use certain tools or something. So it's always better with the student version, whatever workflow we are carrying out, that if you practice, it will be really good in case of you working for any of your projects. Okay, so first let us understand where this space claim can be an add-on advantage for us. Let first advantage is 2D and 3D modeling you can do, sketching and modeling part. Then next you can also work on your assembly part, or you can if someone is working on designing aerofoil or something. So those kind of naka points will be there, right? So those you can import those as an input file, and you can import create your geometry as well using some coordinate points. Then to measure an existing geometry, modify. So whenever you're working, like if you want to just make simple modification, you don't have to get into the sketching zone once again and change it. It's like rapid changes whenever you're working. If you pick out a surface, if you want to drag and give certain changes in it, you can do it. Then next you have working with the STL file. So using facets tab, you can work on your different STL files. When you import those geometries, you can basically work on making them have a smoothened part. Or if you want to I mean to say, like in case you want to have a better you whenever you are importing some STL files out of a simulation done, like let's consider you are working on a topology optimization. So there first you'll perform structural analysis, then you will get the stress concentrated region, and that STL file you'll take it for design optimization, and you will take it into space claim, and you have to give some smoothing to that geometry, right? So their facets you can use it to work on it. And also you can work on additive related problems. Either you have to create the support or orientation. If you have to modify, in that case additive tab can help you out. The most important thing that we consider in terms of working on a simulation is where you design geometry on different platforms. That could be any CAD tool, you can say. It can be SolidWorks, Creo, CATIA, anything. But when you are trying to import it for simulation, there is a GUI change with which you get to see lot of differences in your geometry, and which will not make you have a proper geometry. Let it say your geometry get converted into 2D, or in case of where initially it was 3D, and when you are importing here, due to some data loss, it is getting converted into a surface body. So those problems have to be rectified, and you have to modify them and get the actual geometry. In that case, your repair and prepare tab will play an important role. And let's say someone is working on some problem. So related to beams, there are certain standard libraries existing, out of which you can take those cross sections directly and you can use it, or you can also extract from the existing 3D models. And you need not worry about connecting those beam models, because directly you have a beam connectivity which will help you in terms of having a continuity and the load transfer, what we talk about in terms of beam. So that also you can do it very easily. Then you have direct option to work with contacts, I could say, like wherever you have to assign the bonded kind of connectivity. So if someone is having an idea about contacts, then they will understand that using share and unshare option, you can directly bonded contacts assign in the space claim itself. So when you're taking this geometry to your simulation window, you don't have to work with defining bonded contacts. So that is one of the add-on advantage. And also you can do one more thing, that is whatever geometry you're working directly, you can take it to the different simulation platforms. Let it be working with the mesh, or working with some kind of fluent window, or working with mechanical. So other than that, you have another new feature coming up with the last 2 3 versions, you can see you are able to mesh your geometry using space claim also. So a person who are familiar with workbench meshing, they can proceed with workbench meshing. And people who are interested in knowing, they can also get to learn from space claim, and they can use it for the simulation. And otherwise, people who work on the fluent window, of course, they can go for fluent meshing or workbench meshing or space claim. So they have options available, whichever it is convenient for them, you can go for it. Details tab is basically used for your design sheets when you make drawing sheets, right? So in that you have to specify your dimensions and in-depth detailing of your drawing you need to mention. So in that case you can use your detail tab. Other than that, you have sheet metal section here, which is quite like people who have worked on sheet metals earlier, they will have an understanding that sheet metals nowadays, it is an very important thing to know. If you don't know the 3D tool modeling, doesn't matter, but if you are working with the sheet metal thing, it's really important, because folding, unfolding, and how much material have to be utilized, all that you are able to work it with the sheet metal, right? So in that case, it is similar to your SolidWorks interface, I can say, in case of working with the sheet metal. So all that, if you certain option like certain applications, I'll tell you, in case of giving a proper bend, or if you have to fold your geometry or unfold of your geometry, right? So in that case, or corner reliefing if you have to do. So in all those conditions, you can work with the sheet metal tool, and this is quite sufficient for working with it. Next you have is your tools, in which one you can work with the manufacturing related applications, where you have a standard holes existing, which you can use it for your geometry directly. And also person who want to work with the reverse engineering, let's suppose you are getting some CT scan or something, right? So out of that you will get the surface modeling. So when you want to make out of that some complete 3D solid geometry, if you have to convert, you need to capture the complete region and you have to work it in a reverse engineering way, right? So in that portion, you can make use of this reverse engineering tool. There are certain aligned keywords available based on industry applications. These tabs will be customized. Okay, so other than that, let's focus on how to get started. I hope with this, what are the different applications available in case of working with SpaceClip, you have got to know. So let's begin. First important thing, whenever you're working with CAD, any designing model, sketch plane have to be, sketch plane is most important, right? So what is your sketching plane? Generally, I would suggest whenever you're trying to work, make it as XY as a sketch plane. So in case people who open first time software, they may or may not be seeing as XY as the sketching plane. So just go to file, you have space claim options, and after that you have advanced, and in your advanced section you have a behavior option, right? So in that behavior, just let it change to Z as your top view direction. Okay, and sometimes people would also whenever they are opening software, because of not assigning a proper graphic card, you may face graphic card issues. So in that case, just use your latest version of graphic card here, that will work out. Okay, and just say okay. Or else if you have other settings to carry forward, just let's focus on next. What is the thing that we need to do is to set your units when you're sketching. So you can set this units either to your complete space claim journey, or you can make it limited to your single screen, whatever you're working. So let it be all new documents or this document. So you can change it to either imperial, metric, or in terms of defining length, what is your unit you can define, or for angles you can define. So all these dimensions, whatever you want to want to define the units, you can make from your unit section. Appearance, of course, you can customize your set, and anytime you are losing this like default window, just click on this reset delocking layout. Okay, so these are few new things that you need before getting started. Just you need to have an idea, and then say okay. So all those changes to reflect You need a fresh screen now, which will have your changes done. So go to new and say design. Okay, so you can have multiple windows in your space claim, and whichever you are not working, just cross it off so that only that particular window you have. Okay, so first let us understand, in case you want to, for, because we are saying you are able to do your cleanup of your geometries when you work with the different CAD models. So go, first we have to know what are the file options that you can open it, right? So there are a set of extensions which you can use to import your geometry. So let it be STL format or space claim format, SolidWorks, or you're working on some parasolid geometry, anything you wish. You have almost like all the possible extensions are available here. And if you're not sure of going and selecting serving, just make it as all files. So just type the file name and you will be able to open your file. Let's suppose I open this geometry. Okay, so here's my geometry open, right? Similar way, you can also open any other file that you wish to open. And now let's take a fresh screen and we will understand how to work with designing, right? So first thing, let's understand the sketching tab more and try to start with it. So you have here home window, like anywhere your geometry on the screen it's lying, just click on this home, it will come in the center. Okay, then you can plan your view. Can use either from here or you can use it from this quick toolbar, plan view, to set your plane. Then you have different orientations available, left direction, right, or isometric, trigonometric, whatever is the view you want to have, you can have from here. And the first next you have is to create. So in case of creating, let's suppose I start up with my line creation, right? So I can create my line using Cartesian dimensions or polar dimensions. So by default, when you say it will give you a proper dimensions as well, but anytime you wish to have some Cartesian or polar thing, polar dimensions to be activated, you have in the left side, you can activate and you can use it. Okay, so this is how you need to, for creating a line, you need to define start point, defining the dimension you need, and the end point will be already specified with your dimension, or drag and first point and second point manually you can assign it, right? Then next you have is for circle. So basically you have two types of circles. That is, first you pick out the start point and define the dia, how much it should be, and your circle is ready. And the other one that you have is your 3-point circle. So basically, let's suppose I have a reference point here and I do have a reference point here. And the next reference point with like defining the dia, I can give it here, right? So in that way, define the first point, second point, and the third point you can define. Next, you have rectangle creation. So 2-point rectangle, that is start and end point, you can, where you can specify length and breadth. And in order to modify any of these dimensions, you can make use of this dimension tool and just change it to whatever required dimension. So let's suppose I change it to 15. Right? Then next we have 3-point rectangle. That is, you can give first point, second point, length and breadth you can specify, and also what should be the third point you can specify. Next you have tangent line. So you can create tangent line from here to here, or any tangent line you wish to create, you can use this tangent line tool. Next you have the creation of an ellipse. Okay, so just specify what should be the length here and inner, right? So this is how you can create your ellipse. Next you have for the creation of spline. So wherever you don't want to have a uniform line, you can go using and spline so that you can have a curve coming up, right? So in order to modify the existing curve, basically you can go to your select, okay, and you can see these are your control points. So all these control points you can move and you can play with your curve, right? So you are able to play with your curve. And then next you have is your tangent arc. So in order to create a tangent arc, let's suppose you have this line and this line. Okay. So for go with the selection of tangent arc, and you can create your tangent here. You also have 3 point arc, which you can specify first and second, and what should be the radius. So even using radius, you can create your arc. Next you have is sweep arc. So basically, uh, you can consider this as your center. Select your sweep arc, and it will give you a reference of a circle over which, at certain angle, whichever you want, you can create an arc. Okay, so next, you also have polygon creation. So how many sides you want, you can keep it, and dia how much you want to have it, that you can specify. You also can place points. So basically, when we work on beam creations or coordinates, so when we play with it, we need points, right? So in that case, make use of this points. Also, you can work with create rounded corners. So wherever you have in this condition, you can create the rounded curve. So now here random radius I have specified, but you can specify same or varying, whatever is your radius to different corners you can specify. You also have your offset curve. So you can create offset of the existing line or curve. Okay, so next you have is your trim away. So basically wherever you have a cross path, you can say, right? So this will split out into different selections. So wherever you want to cut down, you slice down, then you just select and you remove it. Okay, so this is how you can trim away. And this is to blend your straight lines. Like you have this straight line and you want to blend it at certain angle. So you can blend it. Right. So this was few tools that we can use it in order to create. Let's get started with something, sketching with taking it to some 2D thing to 3D. So we'll start with one small workshop, which I hope you would have already addressed this kind of tool usage. So we'll try to create some pressure head. So for that, basically, we need to start initially with taking an ellipse. Let's say it's at the center and it's 100. And then what exactly I'll try to do is, before that, let me show you how to convert your geometry into 3D, so that we'll be moving on to our workshop then. Okay, so this is your all 2D and line that you have created. In order to convert them into 3D, you just have to select the surfaces and you get to see an arrow. So along with that arrow, you will see like how much should be the thickness you want to add. So let's say I have 10. So 10 is the 10 mm I have provided the thickness for this one, right? So basically pull tool is nothing but your extrude tool so far that you have used, and pull tool is only option for you available that will help you out in adding third dimension. So let it be creation of your sweep, or let it be for the creation of some revolve, right? So let's try to understand the pull tool first. So in that case, let me just first take other simple geometry creation, and then we'll move on with the ellipse one. Okay, so let's say I have a rectangle and I want to modify the dimension. Okay, so I'll just make this one 20 and this one 80. Okay, so anytime you wish to make it to your screen, just go to your home and click their home button, and we'll try to pull it. So then we'll once again our pull, we can click and we can activate and give the depth. Let's say I give it 5. Okay, now to this one I want to make certain holes to be added in both the sides. So I'll select the surface, go to design and get back to sketch mode. Okay, so in that condition, let me say I want to create it here of n, and also here of 10. Fine. So we have come back to our 3D zone. In case you want to slice it off directly, you can just move it in the opposite direction to slice it, or to add material in the arrow direction. If you pull, you will be able to add the geometry, right? So let's uh, you can do it in this way, or you can move it once again to the same way, and we'll just have one more circle here of something 8, here also of 8, and let's come back to our solid mode. So basically whenever I'm there in my sketch mode, in your mini mac, like you have your quick toolbar, so you can use this solid, return to 3D mode so that you can be out of your sketching. Then select your surfaces, like these two surfaces you want to select, or you can first slice down these two either one by one, or do it together selecting in the same direction. If it is there, you can do it at once. Okay, and you can wish to add it. Okay, so after adding this, you can also, um, using the same pull toolbar, you can give some round feature or some chamfer to your geometry, or if you wish to play with your edges, you can also play with your edges. So let's see first, let me select these two. Okay, these two edges I have selected, and another toolbar get activated for me, which has got round, chamfer, and then edge extrude, and also I can copy those edges and also play with the pivot edge. So let me first go and give a round here. So towards arrow direction, I'm trying to add and say 1. Okay, same thing to both the edges. I'll try to give, let's say 0.5. Okay, and here this is done. And in case I want to create some wall here, so I don't have to take plane or something, directly I can select this edge and go with edge, like extrude edge, so that I'll try to get an edge here. Okay, and now in case of adding some thickness, either on this side or this side, I need to know which side I want to add it, right? So if I want to add it towards opposite to the arrow direction, then I'll click on this plus symbol and move it this side. Okay, and in between these two, if I have to provide support, then Basically I'll need a plane at the center now. Now anywhere I select the surface, I can create the planes here by selecting the surface and creating a plane. So either I can select anywhere and create anywhere that I want, or if I want at the center, then I'll select both the sides and go and click on plane, so it's coming at the center. Now playing with the planes, we'll see how to play with that as well. And I'll take it to sketch mode. Now my plane is selected, getting back to sketch mode. Okay. So if I have to provide some rib, so basically I can take some, either rectangle you take it and you draw this and you can trim it off, or play with the lines and try to get create such thing. So now since your surface is selected here, you can equally give the third dimension here. So for that, you can make use of pull both side and just say to pull it both sides. So what should be the total pull you can define. And any modification you want to have here, just pull it. So that's why we say that whenever you are trying to work with the space claim, anywhere you want to modify, just select the surface, select the edges, and select all those, and you will be able to create it. And let's say I want to modify this surface as well. Like it was, I have given zero point 0.5. So let me add it another zero point 0.5 or 1. I am done adding. And in case I wish to have some chamfer to my geometry, or if I want to reduce anytime, I have reduced it here. And to give chamfer, I can select chamfer from here and give it in this way. So I hope till here you would have understood. Simple, like in the same geometry, I have used too many tools to show you how to work with simple tools, right? So a pull, almost like we have covered using round chamfer and then playing with the edges. Playing with edges is most important because anytime you are trying to modify your geometry, this can give you the reference very easily rather than taking planes and struggling to get your geometry modified. And then if you wish, you can also have a pivot. Let's say I want to make some modification like this. So you can see your geometry is modified. And in suppose the surface you want to make it touch, select the internal surface and say up to select surface. So now this is modified, right? So whatever is the new or few changes that you are doing, you just make sure you are doing with the correct dimensions you have and try to play with that. So I won't say that this is very suitable in terms of dealing with complex geometry. But yes, if you have good experience working with the space claim, you can do that as well. But mostly, space claim people use in terms of modifying the existing geometry. So that how these same tools can be used to modify. Next, you can uh, we'll move on to our workshop which we have just drawn the ellipse. And then so this is one of the workshop, like simple tools that we have used. You can make use of it and try to understand how to work with the sketching. And let's begin with another tool in your pull. So your pull, as I told you, you can also work on working with your revolve tool, right? So we'll start with that. This is our ellipse and I'll need an offset for this one. So let's say I have a 2 at the offset, and I need to, for making it revolve, basically I need a quarter portion of it. So I'll divide this into 4 quarters now. So all our 4 quarters are ready, and all non-required things will select and will delete it. Okay, so let's start with first take an ellipse, divide this into four, then give an offset, or first delete it off, anything you can do, and give an offset of 2. And still here, these are extra lines which I don't need. I just need a curve here. Okay, and basically you will see there will be a continuity as well here. So either you take rectangle or you take line from here and give, uh, it should be 2. So make use of rectangle or direct lines, you make use of it. So my geometry for making it revolve is ready. So basically, let me consider, to start with pull, I'll go with pull and say to revolve. Okay, so for that, basically first revolve will be done around an axis. So axis is selected, then you need to select the edge or the surface you want to have a complete 360 degrees or at certain angle. You can take it, or you can give some reference as well. So to have a full round, you can give full pull. Okay, so full pull you have done and you have got this, or else you can do it manually. So when you tilt your geometry, you will be able to see at certain angle you want to create, you're able to create, right? Or you can just simply say full pull. Okay, so now with this, mostly whatever tools I am explaining you, it's not only about creating your geometry. It's always like when you want to modify your existing geometry, same tools are going to be used. So basically, whenever you're working for your geometry, you would have seen that you will be splitting your geometry into two or splitting your surfaces. So all those things we are going to carry here. So let me consider this as a surface. Okay, so this surface I'll take for a reference of creating some knob there. So let me, and here also you have options like, to zoom from here, it's always difficult to zoom, taking all the time zoom and then doing, rather you can go for control minus and control plus. Okay, and if you want to pan your geometry, make use of pan tool from here. And to spin, you can directly spin, you can enable this one, or you have your middle mouse button to spin it. Okay, so we have taken this surface for reference and we are going into sketching mode. So basically we are not creating here all the time planes, but directly we are taking the surface as reference to sketch it. Come back to solid mode. Now when you come back to solid mode, your geometry is here. So to create some, um, okay, so now if I do it in the opposite direction, basically, I'm able to create this geometry because it was positive direction, right? So you can make use of, remove this no merge. So no merge basically comes out when you don't want to, whenever you're designing two solids, you don't want them to have in a single component. So you can make use of no merge, which last time we have done. And when you say plus, directly, same geometry, it's going to be a part of it and it's going to create. Okay. So when directly, if you do, you will get opposite to the direction, it's going to create a hole. So to have a addition, then go with add. Okay, so we have created this, and for the modification of all these, you can always make move. Now, in case you don't want this internal one to be available, because we cannot take a surface as a reference and we are to create this one. So we are taking this surface as this surface reference, and we have created. But the unnecessary one, we have to split it out. So for that, you can go to your design and you have split body. Okay. So go to split body, select your geometry, and you can give a plane reference or a surface reference to slice the geometry. So this surface I'm giving as a reference, and now I have one solid here and the other solid is here. So the internal solid, if I don't need, I'll just delete it off. Now, if you want this to be an hollow one, just once again go back to your sketch mode. Okay. So just select and you need to delete. Then afterwards, you need to exit from the tool that you're using. Select the surface and get back to sketch mode, plan view, into zoom, control plus, and start designing. Okay, so we'll come back to the solid mode now and we'll try to remove it. Okay, so when you set like that, you are able to get an hollow here, right? So in this way, you can create, and for this kind of geometries, you mostly give a round feature. So just try to give a round here and round feature here, right? So I hope this was a very simple thing that we have considered. In case still here, if you have any doubt, please let me know. And I'm always open whenever the session is going on. We can go for the questions, or at the end of the session, we can go for the session, other questions. Okay, so this is for the creation of round. Then we'll take one more small creation of spline, which basically whenever we are working for any like CFD problem or anything, we do have to create the round like sweep geometry sweep, right? So just I'll take some spline here and select and modify. Okay, and come back to 3D mode. So now you will see in this, like I'll be picking out a point here. You're able to see the arrow and then click on this plane creation. So basically you will be able to create a plane at the point now and come back to your sketch mode. So when you say sketch mode, you can see a detailing here. So there is a shading, you can find it here. See, there is a shading available here, which you can use it for start point of yours. So this is going to be the center of your geometry. That reference is here. Okay, so I'll just zoom out. So you can see here, this is the center point. Select and I'll go back to sketch mode. Okay, and then go back to solid mode. So our profile is ready and also path is ready. So in that case, I'll just select this profile and go with sweep, select the trajectory. So you can either drag manually or you can say full pull. So that complete you are going to get, right? Without an breakage, right? So in this way, you will be able to create your geometry using spline. So there are few more tools that you can basically use. One of more important, I can say you, is your project tool. So let me just show you that. Let's suppose I have some cylindrical object here, component, and over that I want to sketch something. So in that condition, basically to place a plane here, it's a bit difficult. You cannot have it at wherever you want. So in that case, I'll just prefer taking a center line from here and creating plane there. Or I could prefer to select either one of the axes from here, any axis you select, come out of your tools, select one of the axes. So for me, x axis I have selected and click on plane. So I'll get a plane in YZ axis. Similar way, if I select my Z and I want a plane in XY. So XYZ, XY, I'm able to create a plane, right? So if I need a plane in X and Z, then I'll select Y and say plane creation, right? So once this plane is created, I can just move this plane using move tool at certain distance. Okay, and now I can make use of this plane to project something over that cylindrical object. So I have a reference, like this is my boundary of the geometry, which I should not cross it. Okay, and come back to the solid mode. Now this, I can project it on the solid body, and you can see the preview and say okay. So this is how you are able to create some projections, and basically to give some imprint or to create something on cylindrical surface, it's difficult. So there, how just use the project tool and you can create it. Or even the same, you can use it instead of giving project, just select the surface and give up to this surface. So you will be able to create a T joint, right? T section. So, and anything till here you have to discuss, do let me know. Or else after this, we are going for some cleanup things that we can carry out.
Yes, any question from the participants?
Also, you can let me know
Uh,
if I'm going fast, slow, whatever is your opinion, so that I can modify it according to your way.
I hope this we are okay with the space and speed recognition. We're going fine.
Okay. So we'll begin with now just a glimpse I have given in terms of working with the space claim. So there are so many tools are available that you can check out, like split you have, which you can use to split your surface, right? So in this way you are able to split your surfaces. So mostly whenever when we are going for our further workshops, you will understand, like in terms of applying some boundary conditions, how the splitting of geometry is important. So there we can use this split tool to split your geometry, and you can create shell geometry by con uh, you can create shell using shell. You have mirror to create the mirror object of your existing geometry. Okay, so then there are few more things which in the same go I cannot tell, but I can help. I can tell you that you can go with the Ansys help here, which will help you out in understanding each and every tool existing in further anywhere you want to just work with the space claim. Okay, so you have your space claim, each and everything like selecting operation, whatever is existing, all that will be there. So in terms of selecting, how you can use different selections, and let's say you want to go with the selection, so what are the selections are available. And apart from that, if you say you want to do some pull operation that you have seen right now what we have done, so just go with designing pull tool, and each and everything you will be able to see, right? So there are different various options available which you can use it to understand when and where you can use this tool. And also there are lot of tutorials are existing which can help you in terms of understanding the space claim. But the main agenda for us is to work focus on the simulation part. So we'll just move on with the uh, geometry cleanup and preparation one. So let me just open one of our geometry. Okay, so this is one of the geometry you can see here. Now, looking at the geometry, you would have definitely noticed that there are certain changes that has happened to your geometry. So, other than that, you can also look at your tree structure, where you can see you get to see a complete surface bodies are existing here separate. So and the other are solids. So now out of looking at this you can understand that yes, there is some data loss that has happened. So just take 2 minutes of time and come up with your things like what can be done to overcome this geometry whatever issues that we are getting. I want everyone to speak up. If anyone has already worked, they can tell me, or the freshers can also try what should be done. So I think there is no answer. Either people are listening or people are not at all listening. Okay, so in order to have
First and
the complete, yes, yes, is someone saying something?
using this software, the first analysis can be carried out.
Sorry, I'm not able to understand what you're saying. Could you please drop it in the chat so that I can read it out? Okay, so basically by now you have seen that there are surface body conversions taken, right? So those things have to be repaired. So to repair all anything related to solidification issue, you have stitch, gap and missing faces. So these three tools are capable of converting your surface geometries into solid if there is some data loss taking place. So in that case, let's say a stitch where it can be used. So you can uh, like you can say there are two surfaces which are near to each other and they are not connected, so you can use them to convert them into single surface, right? So there you can stitch those two surfaces together. Gaps are there where between the surface edges, near to surface edges, if you see gaps, so there a tolerance value you can specify within which range it should find out, and you can figure out the gaps and you can try to remove those gap issues. Then next you have is the missing faces. So basically for your missing faces, it's showing you two three things that yes, there are certain missing red indications you are able to see, right? So those you can use it for your like looking at like yes, there is some kind of missing faces. So let's first start with the stitch of your geometry, because first when I checked here it was showing there is something needs to be connected. So let's click on this. So you have a green check for completing that operation, and checks with the gaps, there is no gap it is showing. Missing faces, it's showing one missing face now. Earlier it was showing two, but now one. So let's click on this green check and convert it into a solid. Now the solidification issue is cleared out, right? So what could be the other issues? We have to find it out. Now look at this geometry. If you look at it, you are able to see that there is some kind of misalignment between the components has happened, right? So basically you should know that whenever you are importing some geometry here, you will have single component with single color. So there is some kind of different difference in the appearance itself. You can say that there is something wrong. So to rectify this kind of issues, you need to use your interference tool. So this interference tool will let you know where is the interference issue coming up. So basically you can solve this issue using two ways. So one of the way is to measure how much is the interference here, and you can say here this is the start and this is the end one, right? So this what is the distance you need to find out, and use move tool to move it, or you can go with the assembly tool and align those two properly. So let's first start with measuring and say first from where it is starting the interference and the next one, and click on measure. So it is showing there is a interference of 9 mm, right? So now 9 mm you have seen. Come back to, no, we'll just zoom out. So next, either this complete geometry you move it in negative x-axis 9 mm, or these two or internal components. So it's better that we move it out one.
Hello. I think your screen is not visible.
Uh,
Hello.
I'll reshare it.
Okay, okay.
Yeah, now is it visible?
Yes, yes.
Okay. So do you want me to repeat something that you have missed out on the screen?
Yes, students, you should repeat or continue.
We can
Okay,
continue.
I think you can continue.
Yeah, we can
Okay.
continue,
So
Sugita.
yeah. So basically, as I told you, in order to solidify your geometry, you can just use your stitch to stitch out whatever two surfaces they are not connected. Connect them, gaps to find out wherever there are gaps, and missing faces to find out wherever there is a surface missing. So with this, we are converted our surface geometry to a solid, perfect solid. So in that case, next would be to look at this interference that I was telling you, right? So this interference we can rectify it by going to measure and first measuring the start and the end one. So you need to find out, right? So after measuring these two, 9 mm of interference here, just go with the r- repair tab. If someone is asking for the control, please don't ask for the control. I don't see my tools here. Okay, so now you can see here that there is a 9 mm of interference here, right? So let's go with the prepare, and directly we cannot remove it using interference tool because it was in between, it will slice off the geometry, so it doesn't make sense anyways. So we'll go with design and move our geometry. So either that geometry or here we can move it in 9 mm in the negative x-axis. So this is how now we have removed this interference, and you can check if there is some interference existing. So now there is no interference. And the other way is like whenever you are working with the cleanup kind of things, no, you don't see that in a single method. Sometimes your geometry, depending on your geometry, your issue can have different procedures to solve them out. So the other one is to work out with your assembly one. So go with assembly. And before that, we'll have to come to some section view. Okay, so go to section view, and when you go there, you can create the section view from here and click on plan view. And now here, if you look at it, you can see there is some disturbance in the flow of hatching, right? So here itself, you will understand, yes, there is a problem. But when you look at the other portions, it's clear, right? So even in this way, you can like resolve the issue. So we'll go with the assembly, align this and this. So when I move first one this, so this towards this direction it has moved, and here it has created issue. So I'll first move this one. Before that, coming out of tool, okay, now you have seen the alignment is done, right? So coming back to solid. Now also you can see the issue is resolved. So in this way, basically you can resolve your interference issues. These are the two ways, or you can also like assemble your geometry once again. So what could be the other problems that you face in terms of clearing your geometry issues? You have other options, as I told you. In your repair, you can also check for extra edges, right? So like whenever you're importing some geometry, if some extra edges have been created, you can see the indications will be showing here. So let's get on that portion and try to see where are these issues. Let me check extra edges. Still, I'm not able to find it. So in that condition, I'll hide this one. Okay, so now let's check. So here are the two extra edges that are existing. So basically, uh, having extra edges and all will create some problems when you're trying to measure geometry. So those things have to be rectified when you take it to your cleanup. And now, if any of these are not of your interest, like you would have created for applying some boundary condition and still it is detecting under extra edges. So you can remove those. Select those, use this exclude problem and select that. It will turn to green. That means you are giving permission to be available. And the other one, it will remove out. Okay. So, I mean, like for based on your requirement, you can change those. Then next, you can also check for small faces. Now, when some intricate geometries are created, there will be lot of surface creations, not only because of GUI change, but also because of creation geometry, the way it is being created. A lot of surfaces, small surfaces tend to get created. So those you can remove it, and you can avoid element quality criteria. When you don't achieve those issues, you can uh, avoid it. Then to merge two faces, you can use this merge faces. Somewhere I'll try to show it to you. Let's say I have a split of surface here. Okay, so these are the different surfaces. So to merge them out, you can make use of repair, merge faces, this and this if I want to merge. So it will merge it. Or if I say this and this to merge, it will merge it, right? So you can merge your different surfaces into two or more or into single as well. Then in order to remove some round, let's say here or somewhere we have created the rounds, right? So to create remove that, you can use this remove round short edges. Not only when your single edge gets splitted into two or more edges, so there are small edges existing, you can remove those. And in order to create some welded connections, you can make a use of spot weld or weld condition from here. Okay, so let me take you to other simple one more example. Now if you look at this geometry, this is consisting of like bottom portion, if you see, these are uniform cross sections, right? These cross sections have like proper uh, thickness is same, right? Maybe different layers have different thickness, but they for particular component they have a proper thickness. So in that kind, wherever you have uniform cross thickness continued, you can convert them into 2D and you can solve your problem. So let's say I want to convert all these into surface bodies and I want to solve my problems only just for the bottom section I'm talking. Okay, so let me just get into some. Okay. o- okay, so one of the view, I take it and I make use of box selection and say height. So this is my base plate. Now when I look at my geometry, I get to see there are certain imprints existing. So if these imprints are existing, it will create some problem for me in terms of surface body creation, because we spoke of having a uniform cross section throughout. So for that reason, first we'll set our view and select the only imprint you can select, or you can select the complete flat surface where the imprint is done and say delete. So that is gone, right? Next important things, there are small holes existing. Now when we work on simplification of your geometry, like you can have a complete assembly, but when you want to solve it for just a component, you need not need all the other components with you. So we'll remove all the other components and all unnecessary things and we'll try to solve. So in case of me solving this problem, if the small holes are not playing a vital role, I'll just remove those. So for that, I'll do one thing, that picking one by one is little difficult. So I'll just go with some selection option here. And before that, I'll just go with repair and go with stitch or some. Okay, so let's just directly convert it. Okay, so now I can go with the selection directly. Select these two surfaces. Okay, and go with selection criteria, equal radius cylinder, so that all the cylinders are selected here. You can see here, right? So all these are selected. Click on delete. When you don't need all of this, you can remove them easily. Then next you have is to convert all these into 2D bodies. So we have repair once again and then prepare. Out of that, we can make use of mid surface extractions. So one by one you can try to do, but make sure you're not missing out these 3D bodies. So just check that and do. And I'm trying to do it at once. I'm selecting all these geometries, and two different color indications is for when it is trying to take the mid surface of that. It is just an reference for it. So I'll just say okay. and anywhere on the open space you click, and you have converted your 3D geometry into 2D one, right? So let me go back to my complete geometry, and uh, I'll just check on this one so that other conversions what are required I'll show you. So in case of 1D conversion to do, you have extract from your prepare tab. Just go and extract those. I hope it's visible to you all. Okay, so you are converting this into beams. Right now, uh, I'm trying to do everywhere so that few more what all different things I get to see, I can share it to you all when you're trying to work. Now, when you look at this portion, you can see that there is no continuity here, right? So this continuity, you need to manage it by uh, mix, like trying to extend these two. Okay. So for that, basically, you can zoom and you have pull here, select this edge. Now curve one, if you do, then curve extension will create it, big X will create it. So you need to take a flat line, whichever it is there, and go with up to and select this one so that you are able to convert it. Same way here you can do extend, like up to you can use, and this is extended. So in this way you have to extend all this. Here directly you can also make use of uh, extend tool, which you can see whatever are the extents that are it is showing. So if it is having an extra extension, that it will show, or if it is having some like gap is existing, that within your distance that you have specified, it will try to get. Okay, so extend you can make use of it. So I hope you have seen the conversion, and also you have seen how to work with 2D and 1D conversions. So next, let's move on to the next topic of ours today. Okay, so basically when we talk about understanding the any problem that we are trying to deal, designing, I'm assuming that a bit I have given you a glimpse. Next step would be to give you an understanding of how you can get started with your simulation. So what are the different things you will be getting through? So first is like whatever problem you are trying to solve, you need to know the basic set of equations that are going to be solved, so that input values you will be able to give, right? Then you also need to have some geometry with you, some material that you are adding, or working on the mesh, working with more than single component, you need to give load transfer, how it should take place. So connections come into action. And after that, for solving any problem, what is the duration of the time that you want to solve for? Let's say I am solving a linear static problem. So it will be for 1 second. And if you want to solve it for steady state, what are the time steps you have to give, or what type of solver you have to use, what are the output controls you want to have, all those you can specify in your analysis settings. Loading condition comes up for defining the loads and supports, and how to display those loads and support you can you will be checking. And what is the major difference between working with contact and supports? What exactly like we always keep whenever you see any video, or if you have worked on it, you will say we are working with contact, we are working with support. So what exactly that means, and what are different solving modules, and how to get with the results and post processing. So before that, let's have an idea like how exactly an simulation procedure works for us. So first, as I told you, is the problem identification stage, where you will try to identify based on your output what results you are looking for. Let's say I'm looking for an what is the deformation taking place in my geometry. So for that, I need to go for static analysis. And if I'm interested in getting to know the thermal temperature distribution, I have to prefer the thermal one, right? And the other thing that comes out is like when I'm trying to solve my geometry, what kind of simplification I can use it so that my solution get done faster, and I'm doing it in a smart way. So like wherever you it is possible, you can take the consideration of converting your 3D geometries to 2D and 1D. And also you can what to say, you can convert it into certain symmetry condition or cyclic symmetry condition. So any of those assumptions you can make use, and you can try to get your solution faster, right? Then you proceed to your pre-processing stage, where you need to have your geometry, and you need to work on your mesh, define some boundary condition, and also get the results for that. And after that, you need to check for the post processing. So these all things comes up. So let's take a small example where we'll try to work with the flow, which will let us know what would be the flow for our next working. Okay, so let me open Workbench. So whichever version you have, you can open it. Okay, so this is your Workbench where you have different analysis systems, predefined analysis systems are existing. Like you say for performing any problem, let me consider I'm working with a structural one. So material, if I want to define engineering data is there. Then to create geometry or import geometry, I can click on it and work with further meshing connections and doing the setup and solution what I'm looking for, and I can go for post processing. So already a predefined thing is existing, so I can use that, or I can directly work only on engineering, only on geometry, or only working with the mesh. So for mesh, I need a geometry. So the same geometry thing I'm using from here, and then I link it to my uh, like mesh thing from here. Okay, so all this you can couple them together and you can have it. So let's proceed with having one simple geometry. Okay, so I'll just create it here itself. So let's say I have a beam cross section that you have seen in the presentation. Okay, so 50 by 50, I'll consider the cross section here. So I'll just make it 50. And here also 50. Okay, then come back to solid mode and define what should be the length. So it is 1000. Okay, so this geometry is created. I save it somewhere. Okay, and then I come back to my workbench and import the same geometry from here. So that was my recent one, so it's available, and I'll open my mechanical window. Also, when you are trying to start working, no, check with your units what is the set of units being used. Okay, so this is your geometry, and whenever you see question mark, then there is some issue with your geometry. First, you need to check your geometry. Then default material we are using here, Then you have coordinate system. When we are moving further for the session, you will understand how to work with the coordinates. And you have here mesh. So we'll go with the default mesh generation now, and the working with the mesh things we'll discuss tomorrow. And next we have static and insert. So when I say insert, as per my problem, like if you look at my presentation, there was a cantilever beam condition. So in that one side was fixed and the other side it was experiencing some load. So I have vertex selection, edge selection, surface, and also body selection. So I'll go with the surface selection and insert and say fix support. Then next I have in the opposite side, I'll just take a edge selection here and say insert and force. Okay, so now in this condition, you can look at the global axis. So to have in downward loading, I need to give in the negative y direction. So I'll change from vector to component, and in the negative y direction, I'll apply some load here. Okay, so you can see the arrow direction, and for my results I can check for either total deformation, or I can check for directional or some stress calculations if I have to do. So this process enables you to know from the tree like what all different things you are going to work on. So mesh you need to work defining boundary conditions, getting the solution. But when you move on to more than single component, you have to also work on your connection part, and you need to add by default material we have used. You need to work on defining a material as well, right? So you can click on this and try to see the results, and there are results. So you can see the actual deformation, how it is taking place, and stress where it is generating. So basically all these things, when you uh, look at it, by now you would have understood like yes, this is the standard procedure that we are discussing, right? So the same thing you have seen in your uh, presentation here. Okay, so let's proceed further. Like now we have seen how to launch your linear static analysis. Then let's understand what is the like what is the basic linear problem when you're trying to solve, when exactly you have to what is the actual value that you have to give as an input. So when you look at this equation, kx equals to f, now you have k as your stiffness matrix and x is nothing but your displacement vector, but as input f is the load factor. So basically for performing a static one will um, will have to give a force loading, right? So this we have given a loading condition, and since this is a linear problem, we are not considering any time varying factor or some damping effect. Nothing is there. So when you proceed further for the other non-linear conditions, you will have to consider those also, depending on your problem statement. Okay, till here, any questions, do let me know. Sir, can you let me know what is the
Yeah, we can. This means like overall session timing we have is 3 hours. So if you
okay? Proceed with giving you a glimpse about meshing today so that you have an idea of working with the mesh thing. Okay, so let us understand what are the fundamentals of working with the mesh. So is anyone having any idea working with the mesh? Please let me know. I prefer if someone speaks questions or no.
yeah, everyone please.
Well, meshing is a fundamental in some analysis.
Basically, yeah.
Missing
Great. At least you people answered, so happy with that. So basically, let's understand like where what exactly means by meshing. You would have studied in your finite element method subject, right? That you are trying to work with the nodes, you're trying to get the displacement x1 xyz values, all that, right? So exactly the same thing here, that same equations are going to be considered here for solving your problem. You have seen the equation already, right? So in this condition, what exactly happens is when you apply a load on any of the surface. Right now we have applied a load at the edge, right? How that load transfer takes place, for the software to understand, it's always about solving a set of equations, right? So that's how the geometry will be split out into small small pieces, you could say, and those pieces are nothing but your elements, and those elements are made up of some node to node connectivity. You can see the first figure and the second figure how these elements are done, right? So you basically, you can say it's nothing but your geometry is meshed to help you in criteria, that you need to measure geometry properly, so it's coming under mesh quality perfectly. So for that, what exactly we need to do to get the proper mesh quality? You have to understand uh, different methods, what can be used to for different types of geometries, what are local controls, what are global controls, and out of that how to get your mesh quality, right? So that's how we have to um, work for the mesh. So let me say, uh, now we are working on different physics, right? It can be working with CFT or working with mechanical or someone from electromagnetics. So for them, physics is changing, equation is changing, everything is changing. So we need to define what is the preference of physics. Physics preference will give it. Then next, based on the method what you have selected, there are different like elements. Two types of elements are there. Basically, you can say either tet or hex. You say based on that there are categorization of methods. So first, coming up with the tet, you have patch confirming and patch independent. And for hex elements, you do have multi-zone and hex dominant and sweep you have. So for all these, you can work on mesh for 3D, and also you have a automated mesh which we have seen last time. Then for uh, 2D geometry, you have automated method, you have triangles, and you have uniform quad triangles, right? So let me just take walk you through one of the small example I can tell you with the same geometry. Let me remove all the other things here, or else I could take some other geometry. Okay, so same method that we have used so far. We are going to just open a step file, STP file from here, and just open. Okay, so first when I imported the geometry, I am able to see two question marks. So that is because thickness is not specified. Let me just give me a random thickness for these two as of now. Let's say I give it 10. Okay, so I give it. And for the 2D geometry, for meshing, we have seen that there are a set of methods, right? You can go with the automated one, you can go only with the triangles, or you can go with uniform quad and triangles, or you can say you just want to have just the quad view. Okay, so let's go with it. And first, I'll suggest whenever possible, first go with the automated method so that it will at least give you an idea that yes, what component is suitable to go with for the component. Okay, so basically you can see here, this is your mesh, right? So just go with the quality section once and go and say element quality. Now we say that when most of your elements are coming within a range of zero point 0.7 to 1 range, you have a good elements coming up. Now if you look at here, few elements are there which are a bit of poor quality, right? So basically you can do one thing, that is give a sizing control for this, right? So select both the surfaces and click and apply here. So you are giving us geometry selection option here, and default element size it is considering 7. Let's make it as 4 or 5. So let me make it as 5 and say to update or generate. So whenever you're trying to work with the mesh, it's always about you looking at your element quality and then improving, because it will give you an idea where exactly you have to work on your mesh, right? So you can see here 4 doesn't work out for us, so we need to go with something less. So this just to show you other advanced techniques, we'll check it out. Right, so how much ever you do, it's not ready to improve its quality near to the edges, right? So what you can do is just go here, select the edge and say create name selection based on size and say okay. Now you give another sizing control here and change your selection method to name selection, and the name was selection, right? So give it here and give 0.5 as the element size to be aligned here, and just say update. So now basically under your selection, you can see 12 edges are selected mostly. So just go and check here. Now when you say point, when single elements were created, all this we have changed to have and zero point 0.5 of 5 elements getting assigned. So basically these are few techniques which we can use. So and always here also it has created, so you can make use of name selection anytime for figuring out this kind of issues. And as of now, when you look at your geometry here, zero point 0.7 to 1, if your maximum elements are coming up, that is quite acceptable one. But in case you want to proceed further to have good quality of elements, then definitely you have to struggle a lot, and you have to work with the different local controls and all whatever are existing. Okay, so most of our issue with the edges is resolved. So few more techniques we'll see in the further when we are proceeding. So let's understand what else can be done. So let me just take another example for you in case of dealing with 3D problem. Oh, okay, these are all geometries that I have here.
Yeah, Sangeeta, sorry to
Yes.
interrupt in between. There
uh,
is some question in the chat box, if you can see it,
okay.
regarding the meshing.
Okay, one person has given how to work, what is meshing answer, and the other one is how to find the appropriate size of meshing. So basically, There is no appropriate size like what you have to take. Always you should make sure, let's you suppose you should avoid having single element across your thickness, right? So when I'm opening my next geometry, you will get to understand that. I'll take some good example that tomorrow also we can
And
use it.
so to add part, we usually the meshing because end up very high computational cost. It will take a lot of time for you to analyze that problem. And whereas if you take a very less number of elements, then you are sacrificing with the solution. So your solution will not be accurate. So in that case, what you have to do is you have to slowly increase the number of elements in your particular geometry. Based on it, you need to check your results. If your results are converging at that particular meshing size, geometry for each geometry, particular geometry as such, infinite element.
Getting started with meshing, so I would request everyone that when you start with your geometry creation, then you have cleanup of your geometry. I'll be sharing you out the geometry, and then one 2D geometry I'll share it to you. Just try to do a bit of homework. Mesh words that are coming up different, certain for working
Right.
Can,
Along
can
with
you please
view, and I'll put it.
so that everyone can access it through Teams itself?
Yes, yes.
yeah, that would be
Just
better.
allow me some time. I'm working on it.
Sure.
Just now, don't think of FEA. You think any engineering problem is given to you. Let us say you have one cantilever beam and you have asked to find out one load is being applied at the free end of your cantilever beam, and you are asked to find out the deflection of your beam. Okay. So or any of your car model or any system, and you want to find out the stresses, deformation, what would be the fatigue life of your part, and so on. So there are three methods basically by which you would be able to solve any engineering problem. First is an experimental method, then you have analytical method, and then you have a numerical method. Okay. So what is experimental method? You should have a specimen, test specimen, you should have an experimental setup and then you do the testing of it. Now we are taking an example of an cantilever beam, though. So you just fixed one end and you apply load on the other end of your beam and you find out the deflection. So for this particular experimental method, it is time consuming. You have to have you should have a proper setup for that, and a lot of things you have to arrange whenever you are doing any experimental thing. Also it needs cost, right? Because to have that setup for, and you should have to invest onto the specimen or the actual model. So the process becomes lengthy, that is time consuming, and also it needs an expensive setup for that. So, and this experimental method is only applicable only if the physical prototype is available with you. And you cannot just rely on the results. You have to work on minimum 3 to 5 prototypes which you need to be tested, right? So this will be like a lengthy process. So then people came up with an idea about having the analytical method, right? So analytical method is a classical approach. So, and it gives you 100% of the accurate results. This particular analytical results are being used to make use of the infinitesimal elements, and these are typically only applicable to simple problems. So for let us say having a cantilever beam, and we do all the calculations, right? You have the Euler's equation and you do all the calculations and you find out the deformation in the beam. So that is just because you know how to solve any problem for a cantilever beam. But if it comes to the another example of cantilever beam, which is a wing of an aeroplane, so is it possible to do everything by hand calculations? Because it includes lot of changes, right? The shape of the wing is not uniform, right? It is a tapered one. Wing is one of the tapered thing, and it has, again, the cross section is not the conventional cross section, maybe rectangle or circular cross section. The wing has a aerofoil shape. The cross section is in the airfoil shape. Then there are different types of airfoils, right? So it is very difficult to apply analytical method in the complex models. For simple models, you can definitely use analytical method. You can do all hand calculations and you can get 100% accurate results, right? But so though these analytical methods could also give approximate results if the solution is not closed form, and but in general and broad sense, analytical methods are considered as closed form solutions, that is 100% accurate results. But you know, you cannot apply analytical method for the complex geometry or the complex structures. Then the another method comes, which is called as a numerical method. Okay, so this is numerical method. First thing is, it is an approximate method. It's not an 100% accurate method. It is an approximate method, and the approximation can be reduced. Okay, that we will discuss in a later phase, how it can be reduced. So this numerical method is nothing but it's a mathematical representation of your problem. And this is applicable even if the physical prototype is not available. You do not need the physical prototype to apply these numerical methods during the initial stages of your product design. And you can solve all your real life complicated problems with help of the numerical methods. So what is, it has become popular due to the complexity of the problem and the availability of the powerful numerical devices. This particular methods uses the finite size of elements. So any of the system has infinite number of elements. So what this numerical method or the finite element method does, it divides it to the finite numbers of elements. Hence, it brings that infinite degrees of freedom system to the finite level. Hence, the name is called as a finite element method. So the finite element, yeah. So the finite element method is a computer aided mathematical technique, and it is used to obtain an approximate numerical solution to the fundamental differential or integral equations that predict the response of the physical system to the effects. And this FEA method was preliminarily developed by the engineers using the physical reasoning and can trace much of its origin to matrix methods of the structural analysis. So look at this example at the below. You know, this is a ladder, right? So this is the physical system which is shown in the green color. What happens when you convert this physical system into the finite element model? So you divide, basically you divide this whole system into number of elements. Okay. Now the steps of the ladders are being converted into the line elements. You can see the lines, and the red color dots which you can see over here are called as the nodes. Okay, and the horizontal members are called as the elements. So whenever you are given any system, the first thing into the finite element modeling is you have to first divide that structure into number of finite elements. Okay, number of elements you have to divide your structure. Okay, so that is what the key characterization of the finite element method is: the division or the discretization of a continuous body into the finite size of the sub-regions. So these regions are called as the elements. You can see in the bottom, you have one structure. Now, this is the continuous structure. Just a second. So this is a continuous structure. Okay. So now whenever I have to simulate a problem with help of finite element method, what I have to do, I have to divide this structure into number of finite elements. So you can see here, which is a meshed structure, which it is called as the finite element method. Since we have discretized or divided this structure into number of finite elements. Okay. So this particular FEM, that is finite element method, assumes that the governing differential equations of the entire body are also valid for each individual element. And then these equations are transformed into the equilibrium equations. So what this method does, it first simulates or it first solves the individual elements. Okay, and instead of solving the entire region, it first solves it on the elemental level, and later it integrates all the elements together. So these elements are connected at the inter-element boundaries or continuity in terms of the governing functions, and it deviates between the elements is not violated. Later, the summation of the element solutions provides the solution for the entire region. So here you can see how it works. So in practice, the resulting governing equations are in the form of the simultaneous equations. The fact that the same calculations are performed for each element makes this method suitable for computer-aided procedure. Now, how you learned that this is an approximate method. So now how I can increase or how I can improve this approximation, or how I can make the results more close to the accuracy. So the accuracy of this finite element analysis is based primarily on the number of elements in the model. Okay, so let us take an example of circle. Okay, everyone knows the circle. Now you know what is the perimeter of the circle. It's 2 pi r. Okay, now if I am asked to divide the circle into some number of triangles. Okay, let us say if I divide the circle into 8 triangles, you just keep on drawing the diameters. Okay, you would draw a vertical line, then horizontal line, again another line which is at a 45 degrees to your horizontal line, and another one line. So this is how you divide your circle into 8 triangles. Now if you join these 8 triangles, will you get a accurate circle? No, there would be some gap between those edges of the triangle and the circular border, right? So how I will improve the accuracy so that the whole shape of the circle should take place? So what I will do, I will keep on adding number of divisions, right? So I will keep on adding more triangles. I will keep on drawing those diameters again on 22.5 degrees from the horizontal axis and so on. So how I can increase the accuracy is adding the more elements to my circle. Similarly, if you are working on any of the finite element analysis, how you can improve the accuracy of your model, FEA model, is by adding number of elements. Okay, so the more elements and therefore the smaller the elements, the greater would be the accuracy, so that your maximum area would be covered by adding number of elements. However, the more elements, the more unknowns and the more simultaneous equations will happen. So here you can see at the right, you have seen this is size 6, size level 6, which is a default. So whenever you start working on any of the model in FEA solver, what happens? By default, software will generate some mesh. Okay. So by default, it will generate some mesh. But now I know I have to increase the number of elements to make my simulation more accurate. So if I will coarse it, I will reduce the number of elements, the shape would be not as per my model. Okay. So once you can see size level 2 finer. So if once I keep on adding number of elements, so I get somehow close to my model, right? So if you increase the number of elements, then definitely the accuracy would be increased. So the building blocks of finite element analysis or finite element method is the element. Okay, because why? Because you are dividing your whole structure into number of elements. Okay, that's why elements play a very important role whenever you are working on FEA problem. So the finite element is a sub-region that is created when we divide up the body. The governing equations are written for each element, and at the end those are being summed. Each element is defined by its end, corner, and sometimes mid-side locations where nodes exist. So elements are of the simple shapes. Okay, so the elements are of different types. There are 1D elements here. I have given few types of elements at the bottom. You can see. So this is a line element, or we call it as a 1D, one dimensional element. Okay, so this 1D element may be a two noded, that is the at ends. These black circles are called as the nodes of the element. Okay, and sometimes you may have a mid-side node of each element. Okay, then there are two-dimensional elements. The 2D elements, mostly it would be a triangular element or a quadrilateral element. So you may have a triangular or quadrilateral. Triangular element can be three-noded triangular element, and if you add a mid-side node, then it will become a six-noded triangular element. Similarly, quadrilateral elements would be a four-noded element, and if you add a mid-side node, then it will become a eight-noded quadrilateral element. Then you have a three-dimensional element. So whenever you are working with a 3D structures, so you should use a 3D elements. So there would be a tetrahedrons or bricks elements in 3D. Okay, so you can see these pictures of the examples of the 3D elements. So when you will use one-dimensional elements, so whenever you are working, see, there is nothing called 1D 1D kind of thing exists in nature, right? But for our simplification, we consider few structures as a one-dimensional structure, right? Like we solve few problems in our strength of materials, like a beam element, or you do column elements, right? Or you work on the shafts, right? So you consider for time being, just you consider those as a one-dimensional element. Such simplifications you can still do with software as well. You can just consider a beam element as a one-dimensional element. Sometimes you can take the column elements as well as a one-dimensional elements. Okay. Then you have few two-dimensional things, right? You know the conditions. Do you know the conditions? Plane stress, plane strain, axisymmetric, right? So what are those conditions? Plane stress is one dimension, one of the three dimensions is too small than the other two dimensions. Let us take an example of a sheet metal, okay, or the skin of your car or skin of the aircraft, okay. Just consider a sheet metal. So the two dimensions, let us say x and y direction, length and breadth of your sheet metal, it's too large as compared to the thickness dimension of your sheet metal, right? So the change in the stress in the thickness direction is 0, right? That's why we consider such kind of elements or such kind of things as a plane stress, that is a two-dimensional conditions. Similarly, whenever you are solving a finite element problem, you can consider such structures like a plane stress structures as a 2D structures, and you can solve it accordingly. Okay, and that time you will be using these two-dimensional elements. Similarly, you are having a plane strain conditions, right? So what happens in case of plane strain conditions? Like one of the direction is too large than the another two directions, right? So what happens in the plane strain is, let us take an example of your railway track, okay. So that is the best example. The length of your railway track is too large as compared to the cross section of your railway track, right? You can imagine that. So the change in the strain in that longer direction or the lengthwise direction of your railway track is 0. That's why such conditions are called as a plane strain conditions. So similarly, whenever you are solving any of the finite element analysis problem, you can consider those member as a plane strain member. You can consider those cases as a two-dimensional cases, and you can simplify your problem. Okay. So this is how it works. So that time plane stress condition, plane strain condition, or axisymmetric, that is a symmetric about one particular axis, right? So axisymmetric cases, you can simplify your problem and you can consider it as a two-dimensional problem. And the rest of the problems, like whatever model you are working on, you let us take an example of pump housing, or just consider your mobile phone. You can simulate your mobile phone as well. So this is a three-dimensional case. Okay, so such kind of time you will be using this 3D elements. Okay, so I will once check the questions in the chat. Understand? Okay.
You can maybe spend some time.
Sure.
Yeah,
Thanks,
thanks.
Abhimanyu. So, so coming back to again fundamentals. So the one of the another building block of FEA is nodes. So the nodes are we now talked about the elements. You see one-dimensional, two-dimensional, and three-dimensional elements. Okay. Now let us talk about the importance of the nodes. So nodes are the locations where the deformations are being calculated. The deformations at each node are called as the degrees of freedom. Okay. So you know about the degrees of freedom, right? So whenever the example of and the structural degree of freedom is the displacement in x direction or rotation about z direction, right? So for let us say an example of a solid element. Okay. So any of the solid elements has a 3 degrees of freedom. That is translation in x, translation in y, and translation in z direction. Whereas a beam or shell element have 6 degrees of freedom at node. So the degrees of freedom of a beam or a shell element are translation in x, y, and z direction, and the rotation in the x, y, and z direction. So the one finite element equation is written for each degrees of freedom into the model. Therefore, the total size of the stiffness matrix is equal to the total number of nodes times the number of degrees of freedom per node. So, the let us say if you have 1000 nodes in your model and each node has 3 degrees of freedom. So the FEA will be solving 1000 into 3, that is 3000 simultaneous equations. So the results will be the magnitude of all degrees of freedom into the model. So just again for your understanding, I have this is red color dot is a node. Okay. So there are 6 possible degrees of freedom of any of the structural problem. That is 3 translations, translation in x, y, and z direction, and the rotations in x, y, and z directions. Okay. So this is called as the degrees of freedom and the number of nodes. This is how it is related. So before solving any of the problem, you should be aware of the degrees of freedom of your structure. Fine. So these were the basics of FEA. Now, what are the advantages of FEA? The primary advantage of a finite element approach is the complex geometry is easily accommodated. You know, right? We saw 3 methods of FEA, 3 methods of solving any problem: experimental, analytical, and this is a numerical. Fine. So you saw the drawbacks as well of experimental and the analytical method. So FEA is an numerical method. So you can easily accommodate the complex geometry. Also, you can simulate or you can solve the complex non-linear material properties also with help of FEA. Also, you can apply then arbitrary boundary conditions for whenever you are using this particular method. Then commercial computer codes can handle general classes of problems rather than requiring different programs for plane, axisymmetric, 3D, etc. So whatever geometry, whatever structures, whether it is a 1D structure, 2D structure, 3D structure, whether it is a complex structure, maybe it is an assembly, FEA will accommodate any type of structure into it, and you can simulate such problems without writing a separate code for each type of the problems. Okay. So along with the advantages, there are few disadvantages also of FEA. Okay. The first disadvantage is the solution is numerical rather than analytical. So you know the numerical methods are the approximate methods. So but you know now how you can improve the accuracy of your solution, that by adding number of elements. Okay. So you can just make it more accurate by making a good type of mesh. Then significant computing resources are required. You need a good computer for solving for working on FEA. Then large amount of input data is needed for analysis. So whenever you are doing any of a FEA problem, you should first understand the physics behind the your problem. Okay, then only you would be able to solve. So that's why it is saying that large amount of input data is needed. You should first understand the problem, and then only you will be able to analyze your problem accurately. Then large amount of output information to be digested. It will give you a different n type of output information. So you have to pick the one which is necessary for you. And there will be some small modeling errors will be appearing, which will cause a large changes into the solution. So you have to keep an eye on seeing those modeling errors while you are simulating with FEA. So let us now talk about different types of finite element analysis. So with FEA problem or this particular method, finite element method, you are able to solve different types of physics. You will be able to solve structural problem, you would be able to solve thermal problem, you would be able to solve few of the fluid problems and the electromagnetic problems. Okay. In addition, FEA method allows for a combination of physics to be solved together by sequential coupling and by the direct coupling. So I will be discussing on what is sequential coupling and what is direct coupling later. The primary focus of this particular session is we will be seeing the structural problems, but just for your information, with FEA technique, you would be able to solve structural, thermal, fluids, and electromagnetic problems as well. So what is sequential coupling and what is a direct coupling? So sequential coupling is within a solid mechanics, you can run a sequence like a thermal to structure or a coupled of the both thermal and the structural field degrees of freedom. Okay, so it includes the multi-field solver into the sequential or the direct coupling. Now let us see what is the typical design process. So what happens is, in typical design process, you do the proprietary process, that is you do initial sizing and design, then you have a 3D model where you define your geometry, then you build a prototype which includes a high time and cost, then you do experimental. So this is what a typical design process. You do experiment, but if some problem occurs, you again go back to your 3D model for improvement, and again you have to follow this process. So and then your particular product goes for the production. So this particular typical design process includes a lot of high time and high cost for this, because you have to do lots of experiments over here. Now if we convert this typical design process with FEA, if you will apply finite element analysis in this particular process of the designing, then after initial sizing and design, you do all these things, that is 3D model and mesh, FEA simulation, then analysis, optimization, everything you do in a virtual prototyping or in a virtual environment, that is on some of the software. So what happens is your time and cost have been reduced. And once all the optimization is been done, and if you find this in this virtual environment, your model is good to go, then you can do the prototype experimental verification you can do, and you can go for the production. So this is how you can improve your process of designing with help of FEA. So why we do simulation, or why do we simulate the problems? So simulation helps you meet the product code regulations, then it improve the product performance and the reliability. It finds out the root cause failure analysis, and definitely it reduces time and cost of the product development. So this is an overview of FEA modeling. Okay. So I have divided this into 4 stages. You can see 4 colored boxes over here. So first thing is the problem definition. That is defining a goal. This is a very important phase. You should define your goals, and accordingly you have to identify the domain. So what is defining a goal? You should first know what you want to find out. Okay, let us say I have a beam, and if I want to find out the stresses into the beam, that is the stresses in the cross section of the beam, also I want to know the deformation. So I know my output, I want to know stresses and deformation. Okay, so this is my goal. So what type of analysis I should do? Since the output is stress and deformation, I should do a structural analysis. Okay. Similarly, for example, let us say I have a cup of coffee, and I'm putting it into the heating furnace, or I'm keeping that mug of coffee into a microwave, and I want to know the end temperature. Okay, so what output I am expecting is a temperature. Okay, so my goal is temperature, so the domain would be thermal. Okay, so depending upon the output, you have to identify the domain of your simulation. Okay, so this is the first very important step of problem identification. Okay. The next step is the pre-processing. So pre-processing is the things you give as input from your end. Okay. So first is a geometry. You have to prepare a virtual model. There are various modeling tools, as well as you can do modeling with Ansys Space Claim Direct Modular. Okay, so you have to define your geometry. You have to or you can import a geometry from any of the software, and you can use it. Next is a mesh. Mesh is discretization of your model, or discretization of your geometry. So we saw that previously. You have to divide it into number of elements, and those number of elements are joined together by nodes. Okay, so the first mesh is a very important part. Because we have seen how my accuracy of my model, or accuracy of the solution can be improved by having a proper mesh. Okay, so next step is doing a meshing. Next is identifying the physics. Okay, identifying physics is you have to give proper boundary conditions. Okay, so as of now we know different types of supports are there, different types of loads can be done over here, loads can be applied over here, right? So you have to apply the physics over here is the next step. Then you will be doing a solver settings. So various solver settings you have to do. So whenever I will show you one demo where you will understand how the solver settings are being done. Okay. Next block is the compute the solution. You have to tell the software, you have to give a software a command that you run the solution. And the last step, next step is the post processing, that examine the results. You have to examine your results, whether your results are fine or you need to do few modifications into that. Okay, if my results are fine, then it's good. I can go and if my results I feel it is inaccurate or inappropriate, I can go back and I can update my model into, I can go back to pre-processing, and again I have to do all these steps, so my model will be updated. Okay. So why structural simulation? So generally people wants to understand stress, strains, deformation, what is the vibration, what would be the natural frequency of the structure. So for this particular things you can do with the structural simulations. You can simulate various phenomena like composite materials you can simulate. You can do a fracture mechanics, you can do strength analysis, you can do rotor dynamics, thermal effects, topology optimization, drop or impact, and many more. So ultimately, you would be end up reducing the cost and type of your product development without building any prototypes and just by using the simulation. So the goals of the structural analysis are to determine how a structure responds mechanically when it is subjected to external or internal loads. So the solution items of interest include displacements, stresses, strains, reaction loads. Then there are different categories of structural analysis: linear versus nonlinear analysis, static versus dynamic analysis. Okay. So what is linear and what is a nonlinear analysis? So a linear structural analysis assumes that the relationship between the load applied to a structure and the displacement is linear. It means that if double the load, double would be the response or double would be the displacement. So you can see here a force versus displacement graph, and this straight line which is your linear linear behavior of your structure. Okay, so force is directly proportional to displacement. This is called as a linear structural analysis. So the linearity is an excellent approximation for many physical phenomena, and it has been used to successfully design countless very complex components. However, few physical phenomena truly behave in a linear fashion. But there are nonlinear behaviors as well. So you can see this curved graph, right, where your force is not directly proportional to the displacement. Okay, so it is called as a non-linear behavior of your structure. So for more accurate design which required due to the cost awareness and concerns for durability and life require more accurate analysis. So the assumption of linearity gets in the way of accuracy and sometimes must be thrown away to satisfy more rigorous analysis. So there are various nonlinear structures also exist. So what is a nonlinear structural analysis? So it is a more general response and more accurate results are being found out. It is more complicated to set up, run, and post-process nonlinear structural analysis. It is again an iterative solution is required for this particular simulation, and there is no guarantee that a convergence solution will be obtained by doing a nonlinear analysis. Nonlinear analysis takes long run time, and there is a possibility of encountering the structural instabilities while running the nonlinear structural analysis. Whenever you are doing a nonlinear structural analysis, the material behavior may be difficult to characterize, or the test data to characterize it may not be available. So there will be the potential path difference of response while doing a nonlinear structural analysis. And the principle of superposition doesn't apply whenever you are doing a nonlinear structural analysis. So what is the type of nonlinear analysis, or when we should do a nonlinear analysis? Okay. So the typical nonlinear analysis in the finite element includes three types of nonlinearity. If you read a book of FEA, it will again include there are three types of nonlinearity. One is a geometric nonlinearity, then is a material nonlinearity, and third one is a contact nonlinearity or a change of status nonlinearity. Okay. So now, what is geometric nonlinearity? Okay. Let us take an example of fishing rod. Anyway, everyone can imagine it, right? So the fishing rod, so initially it is straight, okay? But once the fish is being attached at the free end of your fishing rod, what happens to the geometry? The geometry of your fishing rod abruptly changes. It becomes curved. So whenever there is abrupt change in the geometric configuration of your structure happens, then it is called as a geometric nonlinearity have occurred into your structure. So what are the different causes of having the geometric nonlinearity? It may be a large strain or large rotation suddenly happening into your structure. Okay. Then you have a material nonlinearity. So what is material nonlinearity? So everyone can imagine the stress strain graph of mild steel, right? So up to your proportional limit or yield point, what happens? Your graph is linear, okay? Your stress is directly proportional to strain. But after yielding, what happens? Your graph becomes nonlinear. It becomes a curved graph, okay? So there are some non-linearities happening into your material. Okay. So the causes for the non-linearity may be plasticity, as we took an example of mild steel graph, right? So your material is, once you keep on loading the material, what happens? From elastic zone, your material enters it into the plastic zone, right? So this is how material nonlinearity takes place, or it is a one cause, that is a plasticity occurs into your material. I can see not at all clear what thing I have to repeat. Nonlinearity. Then another cause of the material nonlinearity may be a creep, okay, or the viscoelastic material. Also, there are different types of nonlinear materials, okay, like hyperelastic materials, like rubber-like materials, like so different types of reasons happening. So whatever the your nonlinear behavior of your material curve, which is being called as the material nonlinearity whenever you are doing a structural analysis. Okay. Now there is another type of nonlinearity which is called as a change of status nonlinearity. Okay. So change of status happens due to contact or birth and depth. Okay. So we also called it as a contact nonlinearity. So there are in FEA, there are 5 types of contacts. One is a bonded, no separation, then there is a frictionless contact, then frictional contact and the rough contact. Okay. So whenever, let us say I have some assembly, or you can just take an example. You can join your two hands together in a namaste position, okay, just to understand. Okay, so now let us say I'm in a namaste position. So bonded means the two surfaces of my, that is the two palms are bonded or glued to each other, and those are not allowed to slide over each other. Also they are not allowed to separate from each other. Okay, so this is called as a bonded contact. Then there is a no separation contact, which is whose behavior is the two palms or two surfaces are uh, allowed to slide over each other, but they are not allowed to separate from each other. Then there is a frictional contact, that is these two palms or two surfaces allowed to slide over each other with some coefficient of friction, and it are supposed to separate from each other. So whenever the contacts or the two surfaces are in contact are supposed to separate from each other due to some application of load, or it has some behavior like that, this is called a change of status. Or so that's why the nonlinearity happens into the structure. And another case is a element birth and death. So now till nonlinearity, I will show you the one demo of how this nonlinearity takes place. Okay. I have done. I have taken a simple model. I have taken a cube. Okay. So I'm just opening my model. So once you open Ansys Workbench, you would be seeing here different types of analysis systems. Okay. So so we were discussing about finding out the domain or physics or the preliminary decision. We were talking about what type of analysis I have to do. So depending, as I said, depending upon the output you are looking for, you have to select the appropriate analysis system. So I'm